My name is Jeremiah Senkpiel, and my talk is called Real World Node Core, or We Broke Stuff, whoops. I'm also known as FishRock123, usually behind this fish avatar, where you can find me on GitHub, Twitter, and everything else. So today I'm here to talk about node issues, specifically two of this year's largest issues, both with separate constraints, histories, and underlying questions. To understand these, let's start by looking at our current release line as it is today, which is scheduled to transition into LTS mode tomorrow, October the 18th. So the v6.0.0 release came out on April 26, 2016, and it was confidently our most stable major release yet. It was backed by 288 test-specific commits, and also new NPM smoke testing for user modules via Miles and James's Sitchem tool. So we were finally able to also check that user modules, at least the ones we were testing, don't break. And v6 honestly went pretty well at first. There was a lot of breaking changes included, but most were very small or edge casey, and very few people seemed to be affected by those. And after release, the first few days, we didn't really have that much in way of issues, even though v6 adoption did pick up pretty quickly. And then we run into things. So the first issue we're going to look at today is fs.realpath, which the entire deal lasted quite some time. And we're going to look at this story in the order where the issue was found and it was addressed, rather than looking in true chronological order, so that you can see exactly our thought process behind this issue. So v6.0.0 shipped with a much more efficient libv-backed native fs.realpath implementation. So native C realpath is about 70 times faster than our JS implementation was. And again, everything seemed OK at first. But then, 22 days after v6 release, this issue comes up. Error, is there illegal operation on directory, binding.realpath. Now this appears to be an odd edge case. And v6.0.0 was a major breaking release, and it was not unexpected that edge cases could come with the new realpath implementation. Now this issue was difficult to reproduce, and it appeared to be related to certain kinds of network drives, and we were unable to reproduce it, so the issue stalled. Some 32 days later, it was attributed to realpath issues on Windows RAM disks. Then 11 days after that issue was reported, another one comes in, that Node 6.2.0 does not work in Docker containers. Now, this doesn't say anything related to what we're talking about here, but if we look in the error logs that are coming up, errors coming from binding.realpath. And this occurred when loading any module in a Windows Docker container, and it was quickly suspected to be related to our previous issue. Then moving on, 43 days after v6 release, we received a much more serious and widespread bug report. So we received this, that realpath had behavior changes. We tried to keep the realpath implementation to be as similar, we thought, as possible to what we had there, but it turns out it wasn't. In fact, it turns out that symlinks and long path names were handled in a much more fragile way than before. And also, errors started varying significantly by differing platforms. One example is that the glob npm module, which at the time of this issue comment was downloaded 1.5 million times that day, when it was run on v6, it pretty much completely broke due to these changes that we didn't really understand before. So, why? Why did we even change this? Well, it comes back to this, the original issue, and that was originally, even before this issue, brought up by the Broccoli build tool was that fs.realpath was about 70 times slower than native realpath. And a quote from that issue is that this is a real problem in the Broccoli build tool where the need to resolve symlinks and hot code paths. Resolving 1,000 symlink files, which is not an unusual case, would take 45 milliseconds alone, slowing down the build considerably. And there's a note attached to that that can't be worked around by using any naive string concatenation or other things, because path resolution system calls require that symlinks be resolved beforehand. So Broccoli is not huge, but it does have a non-trivial amount of usage. And so a node prototype was created, a pull request, for using native realpath, and subsequently a pull request adding, that should be UV, but UV_fs_realpath was opened on livuv. And this pull request spent about 5 months in total in review, about 2 of which were waiting for libuv. So we had to wait for that implementation to be fully sorted out to where they were comfortable with it, and also to where we were comfortable with the new realpath implementation, which took quite some time. And we were pretty confident about it because of that, but we thought there might be some edge cases. So back to where we were in the timeline. While our large symlink problem goes through extra debugging to try and find the best way forward, the issue brought up by Isaac about symlinks and long paths that affected gulp. So we'll posted this about our original issue about Windows RAM disks. And he says if there's no way around the stuff that he lines out, he didn't see any other way to go forward but revert the old code. And that was not a good sign. Shortly after, a meta issue was opened, and it turns out there's 7 issues related to this, 6 of which are Windows edge cases, which might not be easily or fixable at all using a native system call-based approach. And this also includes an issue that was reported before our original RAM disk issue, which was a report only 10 days after v6, but it was not realized that that was related until this roll-up. So after quite some time, our release came out on April 24th, and this PR was made on July 27th. Pull request was made to restore the JavaScript realpath implementation. We finally staged this revert, and it was merged August 12th after review and released in 6.4.0. Total of 108 days since 6.0, 98 days since the original issue, and 67 days since the glob symlink long pass issue was discovered. Also, a postmortem was scheduled for this, but it was never actually completed, so consider this a postmortem of sorts, I suppose. So that's one issue, and this isn't really exhaustive. I wasn't involved very much in fs.realpath, and there's probably still subtle details that I missed, even though I did some deal of delving into the issues. So let's look at another. Again, this is in order of when the issue was found and our process through addressing it. Standard IO Woes. So 4 days before v6, on v6.0.0, release candidate 3. Thankfully, we do release candidates, so stuff like this can be found a little bit before. This issue shows up. libuv upgrade in Node v6 breaks the popular David package. And there wasn't too much information on this, but there was a post of what actually happens with David. And we can see at the bottom, I didn't intentionally do anything there, it sort of just ends, and there's no more output below that. So it starts printing, and then it just stops, almost as if like the process didn't stay alive long enough or something. Shortly thereafter, there was a couple other minor issues that came up but they're not very significant, and they're all rolled up into this that looks at standard I/O buffered writes, chunked issues, and process.exit truncation. So we'll get into that in a couple minutes. But while this is open and people are investigating it, some module issues arise. Commander.js has an issue called not compatible with v6.0.0, question mark. And yargs also has one, help stops finishing to write in Node 6.1.0. Now both of these libraries help with command line parsing, and in many cases they have a help command that prints a lot of information and then stops your node process immediately because there's nothing more to do. So on this sort of roll-up issue about standard I/O buffered writes, after about 15 days, I noticed it. I'm not sure why it took that long, but I didn't really see it before, unfortunately. And it turns out this issue really is not new. An almost identical issue was reported back in Node, or IOJS, version 1. And it says, chunked standard out and standard error drops writes if terminated early. And that sounds awfully familiar to what we just saw of standard I/O buffered writes chunked and process.exit truncation. Process.exit terminates the process and drops output, or can drop output in this case. And so this issue existed in IOJS 1.0.2, seems where it appeared, but it does not exist prior to that, or in 0.12, which from history actually came out after IOJS v1 came out. And this old issue at the time, back before v6 and all that, was determined to happen when piped writes to maybe that's word wrong, but piped writes to piped standard I/O are large enough to trigger the OS level threshold for chunked writes. That is, when a message is large enough, it is broken up into smaller messages. So if you print a ton of standard I/O, that might not actually happen all in one write to your actual standard I/O, whether it be a pipe or a terminal or whatever. And also it was found that writing to pipes, on Unix anyways, appears to be asynchronous. And this greatly complicates the chunking behavior. So writes beyond the chunking threshold appear to happen later because of this, because it's asynchronous. And this causes a lot of problems when the process is exited immediately after writing, because you might get the first write, but then your process synchronous code tells your process to exit, and then you do not get these later writes of all the rest of your information. And so I tried to fix this, but was kind of unsuccessful back in the day. And that was because that just blocking for pipes, so making it synchronous, causes other problems. Specifically, if you have a blocking write on standard I/O to a consumer, such as a pipe to another application, where that application is stuck, then your process might also stall forever, and you wouldn't be able to do anything. So that's not very good, because you probably can't tell that that application is actually, the downstream consumer is actually not doing anything. So much further through digging through old issues, and turns out this is not particularly new at all. In fact, we have this issue. It was reported some 4 years ago. It says, fix blocking/non-blocking standard IO woes. And it has a quote in there that says, currently, now that was current at the time of the issue, process.standard.io is blocking, except when it's a pipe on Windows. Very weird and surprising, very impractical. So you don't say. And also, this other bit was dug up as I was digging things up. So this was the fix to that, was to make standard out and standard error pipes blocking, at least on Windows. So that fixed the original issue at the time, or attempted to anyways. However, it turns out this new problem then only appears on Mac OS and with TTYs. Previously, all the stuff we looked at was only with pipes. So that's a little bit strange. What? What exactly happened in V6? Why did this issue suddenly become so widespread, even though pretty much the same thing already existed before in some form or other, and for a long time too. And we even had a known issue test that specifically tested the old behavior to make sure that we didn't accidentally change anything that might have impacted that. So we knew that that was still a failing test case, and we knew it existed, but still something happened. So bisecting the V6 issues showed the libviv 1.9.0 upgrade is causing the problem. And that sounds fairly easy, I think. However, no change was intentionally made in this libviv upgrade that would have affected standard IO asynchronicity. And this significantly hindered debugging the problem because it kind of hit a dead end. There's nothing there that intentionally that sort of like sticks out as, this might be the problem. So we had to go pretty deep. But we have an old issue, so we can look at that. So when we look at the original issue, we find that libviv standard IO was supposed to be non-blocking since libviv version 1.2.1, which was the libviv version included in a node or IOJS 1.0.2. However, that didn't really appear to be the case, since we know from pipes that it being asynchronous or non-blocking causes some issues when you do certain things. And some of these issues didn't appear until libviv 1.9.0 or node v6. And again, both of these, all the new issues share the same hallmarks as the old issues with pipes. So when we bisect the 1.0 problem, we do show that 1.2.1 has this commit, which sets non-block mode in UV pipe to open. Sure enough, this only affects pipes. So what's up? Let's go back to our issue. So standard IO buffered writes, chunked issues, process exit stuff. Further, while we were debugging, this comment was made that pretty much leads us down the path, a lot better down the path of what actually happened. So the original issue had a trigger threshold of about 64 kilobytes on most Unixes, including OSX pipes, which is large enough to be rarely encountered. However, the threshold of the new problem appeared to be 1 kilobyte, which is pretty small. And if you print out any help information or any significant information of any sort, you're kind of likely to run into 1 kilobyte very quickly. Also, at the same time, a second related issue was discovered, standard IO interleaving. Now this happens when, or happened, still happens in some cases, with async IO for standard IO, if you happen to run into that. So this happens when async writes are chunked when you're writing to standard out or standard error, and then you decide also to write to the other one, so either standard out or standard error. And it kind of causes awful problems because you might be in the middle of, say, writing I don't know, some output, and then in the middle of it you have right intermixed with the no line breaks necessarily, this other information that you were trying to print, and the rest of your information sort of continues. And this really causes awful problems with control characters. And a really good example was the npm progress bar. So npm, when you're doing an install, sort of prints out a dep tree of all your dependencies. And it also has a progress bar, unless you've disabled it, that runs and shows you information on where you're on in your install, And that uses control characters to erase itself so that it looks like a progress bar and you don't really get information that you previously written to your last progress bar update there. So if you had any, so this really becomes a problem if you have any sort of error output that prints the standard error beforehand, because any sort of error output is kind of likely to have an error log that's larger than 1 kilobyte. So you'll get error information, and your progress bar is still running, and it, with control characters, erases half of your error information. So that's not very good. So 20 days of debugging in. Sewell, again, he's a hero on these. Made a giant post and pretty much figured out what happened in libvv 1.9.1. So we'll go through that because it's pretty interesting. So there's some previously made libvv commits that made, the first one makes TTY's async on Unix. And another one made, it falls back to blocking rights if if using the previous commit fails. So what the previous commit does is it opens your TTY via the /dev/TTY Unixy thing. I'm not exactly sure what that's called, but I'm sure someone does. And these commits landed much earlier in libvv 0.11.22, which made it into IOJS, but never made it into Node 0.12. And then moving on to the modern day, so this is stuff that happened before. We tried to make it non-blocking, and then fell back to blocking. Actually, not quite the modern day. So a trick was required for the previous 2 commits to work on macOS, and that was that Unix had to use the select system call for the file descriptor returned from opening /dev/TTY rather than KQ, and that's because, for whatever reason, opening this file descriptor with KQ doesn't work on macOS. So the fun part, the modern day, in libvv 1.9.0, we start to open TTYs via TTY name instead of /dev/TTY. And it turns out the file descriptor works with KQ. And suddenly, everything works in non-blocking mode. So back to where we were again. This is our primary issue, where those comments, the large write-ups and other reported information was, all in all, had 165 commits, and almost all of those are actively discussing what the problem is, where it originated, and how to fix it. Because to understand how to fix it, we need to understand exactly what caused it in the first place. So the tracking issue was opened. That turns out there's 3 distinct standard I/O problems, not including platform differences. So these are that chunks standard out drops, writes have terminated early. Interleaved standard I/O, standard error on terminals, or TTYs. TTYs actually is just a short form for teletype terminals that we still use for some reason or other. And also a missing or truncated error message. So the first and the last issue here are actually still not entirely solved to this day, but are far less common than the middle issue. The first issue is partially solved. It's solved on TTYs anyways. So I opened a pull request to do that on OSX first, to just make it blocking, and that was merged on June 1st after review, 36 days after v6. And the OSX threshold really made getting this in important, because 1 kilobyte is very, very small, and the other platforms don't really have that. But that leaves us in an awkward state where OSX has different behavior than other Unixes. So this pull request was also made, and it made it behavior consistent across the Unix, all TTYs, all Unix TTYs. And that was merged on August 10th after review and released also in 6.4.0, 106 days after v6. So I'm almost done, but state of standard I/O is the current day. Standard I/O on Unix TTYs is blocking by default now. For Unix pipes, it's non-blocking. And that's because of the downstream consumer issue I mentioned earlier. On Windows TTIs, or Windows general, it's kind of the reverse. So it's non-blocking on Windows TTIs. That's because when you have a console and you write to it in Windows, you can't really tell when you're supposed to be done. And it's blocking on Windows pipes for some reason that I'm not actually really sure of and I need to figure out. And there's similar issues whenever, as we just discussed, as whenever standard is non-blocking. So real-world node core. Reality is, sometimes things break. We try to fix them as best as we can. Cross-platform software is really hard with varying platforms. There's a lot of variables in play, little things. It's hard to keep track of them all. Both of these occurred in libv interactions, but these kind of things, issues occur in other places too. We've seen other little bits here and there, but I don't have time to talk about them here. So a quick word on mitigation. Both these issues are avoided by our long-term support releases. When v6 transitions into LTS tomorrow, both of the issues from v6 will have already been addressed for a couple months, so it's free of those. Our current release line is important, though, because it caught both of these. So it's important that people use these so that we actually find out these issues and are able to fix them. So if you're able to use our current releases, please do that, as long as it won't break the world. And we're also moving processes to be, our own internal processes to be in Node Core and the issue tracker to be quicker to revert problematic changes. So that's all the time I have. Thanks. Again, I'm Fishrock123 on Twitter, GitHub, pretty much everything. If you have further questions, please come ask me.